This is Unit 3, Linear Relationships, Lesson 5, Introduction to Linear Relationships. And this is Activity 3, Connecting Slope to Rate of Change. And so what we're going to do in this activity is take the data from the last activity and graph it on this graph. So these are the data. And so it's the number of cups was the x value, and the height in centimeters was the y value. So these are the two properties, number of cups and height in centimeters. We're going to graph that onto this graph. And so what I did is I took that graph and I just drew in bold every 5 units just to make it a little bit easier to graph the points, to see where I am. I did the same thing with every 10 units of height in centimeters. You might do the same. And then I graph the points. So each one of these points comes from, here's the x value, so it's a multiple of 6, 12, 18, 24, 30. And the height is a multiple of 8 centimeters plus 7. So you have to add that 7 each time. So 1 times 8, 2 times 8, 3 times 8, 4 times 8, 5 times 8. But you have to add that 7 each time. So if you graph that, this is 1 times 6, or 6, 2 times 6, 12, 18, 24, 30. And remember we added 3 more cups, which added 4 more centimeters onto the end to get to 51 centimeters. So this is 30 cups, 31 cups, 32 cups, 33 cups, gets you to 51 centimeters. And then you connect those points with the line and you place a couple of these points. You should write in the coordinates for those points, the coordinate pair, the x coordinate and the y coordinate. So this point is at 615. This point is at 12. You go up 12 units and you go up 23 units. This point's at 1223. So we're going to use these points to write both the slope and the equation. So first of all, let's look at the slope. The slope is the ratio of how much there's a change in the vertical measure, so the height in centimeters, compared to how much there's a change in the horizontal measure, which is the number of cups. And so if you count the vertical measurement, there's 4 centimeters, 1, 2, 3, 4, for every 3 cups, 1, 2, 3 cups. So this vertical measurement is 4/3 the horizontal measurement. So that is the slope. So these are 3 units. Divide those into a third, and this is 4 units, but that's 4/3, 1/3, 2/3, 3/3, and this is the 4th third. So it's 4/3. It's 1 more third more than the horizontal measurement. And so if you double that, so instead of 3 cups, you have 6 cups, what's going to happen to the vertical measurement? It's going to go from 4 centimeters to 8 centimeters. So this is 8 right here. So this, from the purple line to the purple line, is 10. Subtract that 1, that's 9. Subtract that 1 right there, that's 8. So this is 8 centimeters. Then if you double that, if you go from 6 to 12, so this is 12 centimeters along this axis here. 12 cups along this axis here. I hope I didn't say that wrong. I hope I said it right. This is 3 cups, 6 cups, and if you double the number of cups to 12 cups, then you double the number of centimeters. So this is 2 groups of 6 equals 12. This is going to be 2 groups of 8 is 16. So this is going to be 16 centimeters, and that's what this measures. This is 9 to here, from this point to this point, 10, 11, 12, 13, 14, 15, 16 centimeters. All right, so now that we have that, we can start writing, we know the slope. Now we can start writing the equation. So let's go back and let's add that slope triangle. So now remember, the slope is the ratio of the vertical measurement, which was 8 centimeters. And where do you get 8 centimeters? That's 15 minus 7. So you have to subtract these 7 centimeters, which is the first cup, the base of the first cup, to get to the first rim. So you subtract that 7 centimeters and you get a height of 8 centimeters. When you have how many cups? Well, when you have 6 cups. So it's that ratio of 8 centimeters to 6 cups, and that simplifies to 4 centimeters for 3 cups, or 4/3. The vertical height is 4/3 the horizontal number of cups. All right, so now how do you get the equation? So that's the slope. And remember, it's 15 minus 7 is that 8. Remember that because this is against the y-axis, then 6 minus 0 is 6. That is that coordinate right there. That x value is the number of cups. It is the measure along the x-axis. So that's what happens when you move the slope triangle over to the y-axis. And if you moved it down here, then the y coordinate would be the measure along the y-axis. And it's not moved down there yet. We're going to move that in just a moment. But along the x-axis, this is 6 minus 0 is 6 units. So that's just x. We'll get to that in just a second. So the slope is the measurement in the vertical direction compared to the measurement in the horizontal direction. So that's 15 minus 7 is 8 once again. And 6 minus 0 is 6. That 8/6 is equal to 4/3. So the measure in the vertical direction is 4/3 the measure in the horizontal direction. So 8 is 4/3 of 6. 1/3 of 6 is 2. 2, 4, 6, that's 3/3. And then one more third, which is 2 more units, gets you out to 8, in this case 8 centimeters. So that 8 is 4/3 of 6. 6 divided by 3 is 2. 2 times 4 is 8. All right, what about the left side of the equation, the x's and the y's? So we always start out writing the slope on the right side and get all the x and y values on the left side as we begin to write this equation. Well, the left side, that y value is the vertical measurement. You have to subtract those first 7 units to get down to, actually it's to remove that base of that first cup. So I'm going to subtract 7 units from here. So this is going to be y minus 7. So that means it's 8 centimeters if you have 6 cups. So y minus 7 compared to the x-coordinate, which is just the measure along the x-axis. It's the x-coordinate, which gives you the horizontal measurement. So that's x. So y minus 7 is the measure in the vertical direction, and x is just the measure in the horizontal direction. So y minus the 7. So now we're getting rid of the base of that cup, and now we're looking at just the rim. So y minus 7 is equal, and y minus 7 compared to x minus 0, which is just x. And so what does that ratio equal? Well, that equals 4/3. That's the slope. So y minus 7, once again, is going to give you this vertical measurement. And x is going to give you the horizontal measurement. So that ratio is equal to 4/3, the slope. Now, notice, and we've said this again over and over, that this vertical measurement is 4/3 the horizontal measurement. So if you just say that in words, the y value, or the vertical measurement, I shouldn't say this, the y value, y minus 7 is 4/3 the horizontal measurement. So y minus 7, this is the vertical measure, is 4/3 the horizontal measure. So it's 4/3 that x. So y minus 7, we know it's going to be 8 in this case. And so 4/3 of x is going to be 6. So 4/3 of 6 does equal 8. If you plug those in, and notice what's happening now. To get the y coordinate, you have to add the 7 units back. So to get the actual height of the cups, you have to add the 7 centimeters from the base. So you have to add that 7 centimeters back. So you get the equation y equals 4/3 x plus that 7 right there. Where's that 7? You're adding the 7 units back to the base. And so what do we know now about this situation? We know that it's not proportional. How do we know it's not proportional? Because it does not go through 0, 0. It doesn't go through the origin. It goes through 0, 7. It goes through the y-axis up here. It does not go through this origin. The line that we're talking about is this orange line, which goes through 0, 7. And the ratio of the coordinates are not equal. And we saw this before. The ratio of 15 units in height to 6 cups, that was 2.5 centimeters. And the ratio of 23 centimeters in height to 12 cups was 1 9/10 centimeters. So those are not equal. It is not proportional. To have a proportional relationship, these ratios have to be equal. The ratio of the coordinates have to be equal. That would be called the constant of proportionality. But these are not equal. And the slope is 4/3. So after the first cup, the increase in height is 4/3 the increase in the number of cups. So you get rid of that first cup, then the increase in height. Every time you add another rim, it's adding 4/3 of 4/3 centimeters. So the slope is 4/3 centimeters for every cup that's added, or a ratio of 4 centimeters to 3 cups. So the line intersects at the y-axis at y equals 7. So what you're doing is you're getting rid of that base, and actually at 0 centimeters is 1 rim. Zero centimeters, 0 centimeters, where the first rim begins. So it's not 1 rim, it's the beginning of 1 rim. So it's actually 0 rims, but it's right at that point where you're going to start measuring the rims. So you're at 0.7 centimeters, 7 centimeters of the first cup of that base that you removed. So after the first cup, then each cup added adds 4/3 centimeters. Well, you can look at it as the first cup. If you take off the base, that's 1 cup, or 1 rim. Maybe you should count rims instead of cups. 1 rim gets you to 4/3 centimeters. 2 rims is 2 times that. 6 rims is 6 times 4/3, or 4/3 of 6, or 8 centimeters. So after the first cup, each cup adds 4/3 centimeters in height. I should say after the base is removed, each cup adds 4/3 centimeters in height. That's the rate. How much are you adding each rim or each cup? Where you're adding 4/3 centimeter. So 4/3 centimeters per 1 cup. And actually I think about changing this maybe to per 1 rim, because you're really adding rims as you're adding cups, but kind of that takes care of that first cup where you remove the 7 centimeters. So this is the conversation to have. How do you explain this mathematics to somebody else? And there's lots of ways to think about it, and you have to just develop your own way of thinking about it within the context of the problem. You can't make stuff up. It has to make sense. But you might just explain it slightly differently or understand it slightly differently than somebody else. But the math is going to remain the same, however you explain it to yourself in words. All right, this is activity 3.